Welcome back to Air Quality Matters. I believe we already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones and this is episode 49. On World Ventilate Day, if we're serious about ventilation, then we may need to think seriously about how we measure ventilation. I had to shuffle a couple of episodes around this week, so much like a bus, I'm sure you've been waiting for a solo episode from me for ages. Then two come along at once, lucky old you. In this episode, I've been thinking about where the measuring of ventilation is heading. In this part of the world at least, there is more and more focus on the performance of ventilation systems in both residential and non-residential settings. But it seems to me at least that throwaway phrases like measure the performance of in various documents may not have thought through the implications of that ask. And if you hang around to the end, perhaps a two-tiers approach might be the solution. Thanks for listening as always. Do check out the sponsors in the show notes and at airqualitymatters.net. This is the Air Quality Matters podcast. World Ventilate Day reminds us just how crucial good air quality is for our well-being. But why stop there? Ventilation plays a foundational role in creating healthy indoor spaces, impacting everything from our physical health to our cognitive abilities and overall comfort. In fact, the importance of ventilation becomes even clearer when we consider that most people spend up to 90% of their time indoors. That means if you're lucky enough to live to 80 years of age, you'll spend close to 70 of those years inside. And despite this, the air inside our homes, schools and offices is often more polluted than the air outside. This pollution comes from common household products, cooking, building materials and even poor ventilation itself. If indeed it is the largest single environmental risk we face, and the long-term health consequences range from respiratory diseases to allergens and cardiovascular issues and even cognitive impacts, most of the evidence now points to not a single organ in the body being immune from the impacts of poor air quality. And in light of recent events such as COVID-19, the importance of ventilation should have become even more apparent, especially in shared spaces like schools, workplaces and healthcare facilities. Proper ventilation is essential to reducing the transmission risk of airborne diseases, but it's equally vital for ensuring overall indoor air quality in the places that we live, work and learn. Poor ventilation allows pollutants and allergens to build up. According to the Harvard T.H. Chan School of Public Health, poor indoor air quality can even reduce cognitive function, decrease productivity and increase absenteeism rates in schools and workplaces. In residential settings, poor indoor air quality, amongst many other things, can worsen conditions like asthma and increase allergy symptoms. In fact, 55 years of your 80 years of life are likely to be spent in your own home, where pollutants like particulate matter, formaldehyde, products of combustion and many more present as serious a risk to your long-term health as smoking. Harmful substances like radon, a naturally occurring gas, can build up in homes with insufficient ventilation, posing significant health risks. Radon is the leading cause of lung cancer among non-smokers and is more likely to accumulate in buildings where airflow is restricted. For me, the evidence could not be clearer, yet often when we check the ventilation performance in these spaces, we find lacking. And one of the ways we have in addressing this problem is by measuring it in the first place. Why does accurate ventilation measurement matter? Well, while many of us agree that good ventilation is essential, ensuring it is another matter. Without accurate measurements, it's impossible to know if a building's ventilation system is truly meeting our needs. Standards like the Building Regulations Approved Document F in the UK and similar guidelines worldwide outline many ways to assess airflow. But these methods vary in reliability depending on the tools used and the specific conditions of each setting. For instance, studies in the UK show that up to 38% of domestic ventilation systems still fail to meet the required airflow rates, despite considerable advances in testing and installation practices. This performance gap highlights the need for improved measurement techniques that ensures indoor environments remain healthy, safe, and compliant with indoor air quality standards. As the understanding of indoor air quality's health impact grows, our challenge is twofold. First, to ensure that all spaces meet minimum ventilation standards. And second, to continually refine measurement methods so they can reliably inform decisions that promote healthier indoor environments. Moving forward, this dual focus will be essential for creating spaces that truly support our health and well-being. None more so than in residential settings where we spend most of our time. And it's this measuring of ventilation systems, believe it or not, that is a relatively new concept for many. So it's here I'm going to concentrate. To maintain healthy indoor air quality, clear standards and reliable methods for measuring airflow are critical. Industry standards like those outlined in the BISRIA Guide, Domestic Ventilation Systems, a guide to measuring airflow rates, training through the likes of ATMA, NSAI in Ireland and others, typically define three main methods for measuring ventilation: the unconditional method, the conditional method, and the minimum benchmark method. Each of these has specific applications, strengths, and challenges, especially when applied to mechanical ventilation systems in domestic settings. The unconditional method, also known as Method A in the BISRIA Guide, is the most accurate approach. It relies on powered flow hoods to measure airflow directly by balancing any pressure differential created by the measurement device itself. The conditional method, or Method B, is a more accessible yet less precise approach. It uses a vane anemometer to measure air velocity, converting these readings into airflow rates using specific correction factors. Unlike powered flow hoods, vane anemometers can create back pressure, especially when used at higher airflow rates, which can skew readings. Both BISRIA and ATMA in their training recommend applying tailored correction factors to approximate the true airflow. But the complexity of this process demands careful handling and experience. And finally, the minimum benchmark method. For situations where simplicity is key, the minimum benchmark method, or Method C, provides a streamlined approach, if you like. This method sets a baseline airflow rate that fans must meet. According to BISRIA and others, this method is typically used for dwellings with axial or decentralised fans and background ventilators. While the minimum benchmark method is practical, it sacrifices accuracy, making it ideal only for routine inspections or cases where minor deviations from extract performance can be tolerated. So what are the advantages and challenges of ventilation measurements like these?
I'll have you back to the podcast in a minute. I just wanted to briefly talk to you about 21 Degrees, a partner of this podcast. Formerly the Green Building Store, they were founded in 1995 by three exceptional building professionals. The company grew out of their frustration with the poor availability of ecological building products. I've known them for years as the go-to company in the UK for end-to-end design-led MVHR systems. We spend the majority of our time in our homes, so they should be the best they can be, comfortable and healthy to live in, with exceptional efficiency. In fact, life-changing homes. At 21 degrees, you won't find a more trustworthy, straight-talking, passionate about what they do, and approachable group of people. I speak a lot about the performance gap on this podcast and what we can achieve if we value ventilation highly enough. 21 degrees embodies that sentiment for me. So if you're building a home, looking to install ventilation, or need to talk to experts in the field, I can't recommend them highly enough. Links are in the show notes at airqualitymatters.net, and you can Google We Are 21 Degrees. Now, back to the podcast.
With indoor air quality's growing significance, standards like PAS 2035, BSEN standards, RICS guidelines and many more underscore the need for reliable ventilation testing in residential buildings. Each measurement method has its benefits and, to be frank, its drawbacks. With the unconditional method offering high accuracy, the conditional method a balance of affordability and precision, and the minimum benchmark method a kind of quick compliance check. However, achieving reliable results also depends on the competency of those conducting the measurements. Let's take the unconditional method, or method A, as an example and look at things like accuracy at a cost. The unconditional method is ideal for high precision applications when you want to know exactly what a flow rate is. But its cost and complexity often limits its use. Powered flow hoods are expensive, and the training required to use them effectively often restricts this method for a lot of professionals using them day to day. But standards like PAS 2035 and RICS guidelines increasingly call for qualified practitioners to handle these measurements, as improper handling can lead to significant errors. Given the high costs though, the unconditional method is often reserved for new construction and formal commissioning, where compliance accuracy is crucial. And this is where things like the conditional method steps in, an accessible but skill-dependent approach. The conditional method provides a more affordable option by using a vane anemometer, yet it does require an understanding to apply necessary correction accurately. This method is widely used in the field, but back pressure issues mean that an experienced operator may struggle at times to produce consistent results. The conditional method's affordability makes it popular, but it demands trained practitioners to ensure meaningful results. It isn't a silver bullet. And then we come on to the minimum benchmark method. Practicality over precision in many ways. The minimum benchmark method allows for quick ventilation checks without requiring exact readings, making it suitable for, let's say, routine inspections. However, this approach is not appropriate for settings where precise airflow validation is necessary. While effective for general compliance, it's not recommended for consistent, accurate results when they're required. There's another problem here though, and that is that there is often a very big gap between the training and experience new entrants get in measuring airflows and the realities of measuring airflows out there in the wild. With cupboards where you don't want them to be, blocking access, unusual grills, poor locations and access, and just the normal shenanigans of field measurements, to be honest, we find the realities of actually getting consistent results with many of these methods not happening out there in the field. Conducting a straw poll for this podcast, it was clear to me, at least talking to the testers in a number of jurisdictions, that many had no idea of the limitations of some of these testing methods, nor did they get any kind of training for what to do with common edge cases. Everyone agrees, at least I hope they do, that validating the performance of ventilation is a critical step in improving outcomes in the sector, and it sorely needs it. But in my view, the guidance is hopelessly out of date for the systems that people encounter out there. There's no plan B for the realities of field measurements, and a regulator that quite frankly is only going in one direction towards powered flow hoods and unconditional testing methods, and a sector that desperately needs to get testing equipment into the hands of many. In Ireland, we face the very real problem that the validation of ventilation is a requirement of regulations, yet the validation scheme is frankly failing. With thousands of euros of equipment unable to pass the test to be used for validating, an increasing reliance on the one testing method that is being phased out elsewhere, and a sector that just isn't trained to conduct the work. So perhaps there's a two-tiered approach to ventilation measurement that may be possible here. Given the growing emphasis on indoor air quality and the complexity of ventilation standards, a two-tier approach to measurement could strike a balance between accuracy and practicality. This model would place certified professionals in charge of formal measurement, while allowing less technical personnel like general maintenance workers, housing officers and stock condition surveyors and so on to conduct basic assessments. This approach might make it easier to meet regulatory requirements without overextending resources. So what do I mean? Let's take Tier 1 for example, the formal assessment by certified professionals. In the first tier, trained, I repeat, trained and certified professionals carry out high accuracy tests using methods like the unconditional approach. These detailed assessments are vital in projects requiring precise airflow data, such as formal commissioning or settings with vulnerable occupants or so on. Professionals using powered flow hoods in line with standards can provide reliable insights into system performance, helping to inform any necessary improvements. And that then leaves a potential second tier, a tier 2, basic assessments by non-technical people. In the second tier, simplified tools and basic indoor air quality benchmarks can be used by general maintenance staff, housing officers and other non-specialists. The practical tools such as handheld anemometers with hoods allow these personnel to conduct rough ventilation checks, which can signal when professional follow-ups might be necessary. This approach aligns very well with what is basically the minimum benchmark method, providing a manageable way to monitor indoor air quality without requiring costly tools or extensive training. A two-tier approach effectively maximises the impact of trained specialists while engaging a broader network of building personnel, which I think is so essential here. However, its success depends on standardised checklists and clear escalation protocols for non-specialists to flag concerns. With the support of fairly brief training sessions and effective tools, general personnel could contribute to indoor air quality maintenance, ensuring minor issues receive attention without necessary delays. The reality is there is a place for accurate commissioning, but equally a place for kind of ballpark measurements, or the minimum benchmark method if you like, to capture the cluster whatnots that we see far too often. Either way, there's a very long way to go and a considerable amount of investment and time and resources to lift the testing sector to where it needs to be. If the revisions of ADF, that's the UK regulations, make it through in its current form, it is all but going to rule out the conditional testing method anyway. This is going to put a shock to the system. Powered flow hoods in the UK market are probably only in the hundreds, in Ireland maybe in the dozens. We're going to need to add a couple of zeros to these in the very near future and build the competency along with it. And I say this quite often, but imagine a world where it won't matter what you said it did when you installed it. Here, you are judged on the ongoing performance of these systems. That digital world is not very far away, and if we can't get measuring a bit of airflow right, we're in deep doo-doo in a few years' time, I can tell you, when we start to see environmental monitoring becoming more prolific. Thanks for listening as always. Before you go, can I ask a favour? If you enjoyed the podcast and know someone else who might be interested, do spread the word and let's keep building this community. This podcast is brought to you in partnership with 21 Degrees, Lindab, ACO, Ultra Protect and Imbiot, all great companies who share the vision of the podcast and are not here by accident. Your support of them helps their support of the podcast. Do check them out in the links and at airqualitymatters.net. See you next week.